In today's video, we are going to evaluate the integral using residues. So in this video, I am going to evaluate integral 0 to 2 pi d theta by 5 minus 3 sin theta whole square using residue theorem. So as always, I am keeping z value as e power I theta. As you know that e power I theta is nothing but cos theta plus this value is I sin theta. So if I apply modulus on both sides, this is mod z is equal to, this is modulus of cos theta plus this value is I sin theta. So mod z value is equal to, so this is root over, this value is cos square theta plus the value here is sin square theta. Here mod z value is clearly 1. So this is the region with center 0 and radius 1. So this is the unit circle. So we are going to discuss this integral in between the region that is with center 0 and radius 1. And next thing is, for the integral we need d theta value and sin theta value. And the next thing here is, for sin theta what we have to do? For d theta, so here z is equal to e power I theta. If I make a derivative on both sides, dz value is equal to e power I theta is again e power I theta and I into this is d theta. So e power I theta is nothing but z. So this value is zi into d theta. I need the value of d theta. Therefore d theta is equal to dz by this value is z into I. So after getting d theta value, I need the value of sin theta. So for getting sin theta, what we have to do? So sin theta value is equal to, as you know that sin theta can be written as, this is e power I theta minus e power minus I theta by this value is 2i. So this is sin theta is equal to z minus z inverse by 2i. So sin theta value is equal to z minus 1 by z by this is 2i. 1 by z by this is 2i. Therefore sin theta value is equal to, this value is z square minus 1 by this is 2zi. So we got the value of even sin theta. So therefore if I substitute all these value of d theta, sin theta, and the region here is also known, that is mod z is equal to 1 in this integral, that is integral 0 to 2 pi d theta by 5 minus 3 sin theta whole square. So all these values if I substitute here, this will become, that is integral 0 to 2 pi, integral 0 to 2 pi. What is d theta value? This value is dz by, this is zi by 5 minus 3 times of, what is sin theta value? This value is z square minus 1 by this is 2zi whole square. So this value is whole square. Now this can be integral 0 to 2 pi, this is dz by, if I bring this zi down and see here, if I take 2zi as LCM, so this will be 10zi minus, if I multiply, this will be minus 3z square plus 3, this is whole square. And see, this will become integral 0 to 2 pi, this value is dz by zi into, so if I take minus also, if I take minus common from this, minus 1 square is plus. So I am taking minus 1, minus common from this, that is 3z square minus 10i into z plus, so this is minus 3 whole square by, so this is 2 square, this is 4, this is z square, I square, this is minus. Clear? So if I take minus common from this, so this will be plus and the remaining 2 will be minus. So if I send it to the numerator, then see what happens here. This will be integral 0 to 2 pi. This is minus 4z square into dz by, this value is zi times of, this value is 3z square minus 10i into z minus 3 whole square. Now I can cancel this one, z for one time, and in place of minus I am writing, see here, in place of minus I am writing I square, this is 4z into dz by, this value is I times of, this is 3z square minus 10I into z minus 3 whole square. So I can cancel even this I for one time. So this will be 4I. It is a constant. This is integral 0 to 2 pi. This value is z dz by this is 3z square minus 10I into z minus 3 whole square. Now what is our f of z value? So f of z value is nothing but, so this is integral f of z into dz. Therefore our f of z value is clearly as 4iz by this value is 3z square minus 10I into z minus 3, this is whole square. So as usual, so if I want the poles for the given equation, what we have to do? So we have to equate the denominator to 0. So if I equate this denominator to 0, so this will be 3z square minus 10I into z minus 3 whole square is equal to 0. So whole square also, if it goes inside 0, it will be 0. So this value will be, this is 3z square minus 10I into z minus 3 is equal to 0. 3 3s are, this is 9. For 9 factors, that is 3z square minus, see here, there are no roots ready for this. That is 3 3s are 9 and minus 9 minus 1. This is minus 10, but it will be plus. So here I am writing as it is like this. So here is the formula for this. So what is the formula? The formula is minus b plus or minus. So this is minus b plus or minus root over b square minus 4ac by 2a. So if I substitute here in this formula, so this is a, so this is b and this is c, that is minus b, that is 10I plus or minus root over b square, that is 100 into I square is minus 1 minus 4 into a into c, that is minus of minus plus 3 3s are 9 by 2 into 3. So here the roots value are 10I plus or minus root over minus 100 plus 36 by 6, and therefore this value is 10I plus or minus root over minus 64 by 6. 64 is again 8 8z, so minus here I square, so this will be 8I by 6. So here if I add up for one time, so this will be 10I plus 8I by 6, and next one 10I minus 8I by 6 is the another root. Let the roots be alpha comma beta. I am taking this as alpha and this as beta. So alpha is equal to 18I by 6 and beta value is equal to 2I by 6. So here alpha is equal to, the value of alpha is equal to 3I and alpha value is equal to I by 3. So clear? These are the two roots. So now we are going to call this as poles. So if I equate the denominator of f of z to 0. So if I equate the denominator of z to 0, I got the two poles. One is 3I and one is I by 3. So let us check whether these are inside or outside or on the circle. So as you know that this is mod z value is equal to 1. So this is a circle with radius 1. So this is 1 and this is I and this is minus I. So 3I is outside. So this is outside. So alpha value is outside the given circle and beta value is, so this is 1 by 3 is 0 point, sorry this is, so this is I by 3. So this value is inside the circle and this value is outside the circle. So here beta is inside and see beta value is inside the given circle. So the interior pole is beta and the exterior pole is alpha. As beta value is less than 1 and alpha value is greater than 1. So alpha, we have to find the residue for this pole. So in order to find the residue, so here is I by 3. For finding the residue, again I am modifying this f of z. So what is our f of z value? So f of z is very clear as, here it is, f of z value is this one. So f of z value is 4iz by this value is 3z square minus 10iz minus 3 whole square. Clear? And here our alpha and beta values are, so alpha is equal to plus 3I, so alpha is equal to 3I and beta value is equal to I by 3. Very clear? And therefore I am modifying this one as f of z value is equal to, I am writing this as See here, this can be written as f of z is equal to this is 4I into z by, if I take 3 common from this, 3 square, this is 9, so 9 coming out, so this is z square minus 10 by 3I into z minus 3 by 3, this is whole square. So this can be written as f of z can be written as this is 4iz by 9 times of this is z square minus 10 by 3I into z minus 1 whole square. So as we can see the sum of the roots, this is alpha, so alpha is equal to 3I and beta is equal to I by 3. So if I add up these two, this will be 3I plus I by 3. So alpha plus beta value is equal to, if I take 3 LCM, this will be 9I plus I. So alpha plus beta value is equal to 10I by 3. Clear? This value is 10I by 3. And if I multiply these two, alpha and beta, this is 3I into this value is I by 3. 3 3 got cancelled, and this is I square. I square value is minus 1. So I got the value of alpha plus beta as 10 by 3. Clear? This value is 10 by 3 and alpha beta value is minus 1. So here in this I am keeping in place of 10 by 3, I am keeping alpha plus beta. See here, f of z is equal to 4I into z. 9 I have taken common. This is z square minus 10 by 3. In place of 10 by 3, this is sum of the roots, and minus 1, this value is product of the roots. Clear? Whole square. So f of z is equal to, see here, f of z is equal to, this is 4I into z by 9 times of, inside if I multiply, that is z square minus z alpha minus z beta plus alpha beta whole square. So f of z value is equal to, that is 4iz by 9 times of, if I take z common, this will be z minus alpha. If I take beta common, this will be again z minus alpha whole square. So f of z value is equal to, see, f of z value is equal to, this is 4I into z by 9 times of, if I take z minus alpha common from these two, so what remains, this is z minus beta whole square. Therefore our f of z value is equal to, so f of z is clearly as 4iz by 9 times of, this is z minus alpha whole square and this is z minus beta whole square. So after getting our f of z value, so this is our f of z. So f of z is very clear as this is 4iz by 9 times of, this is z minus alpha whole square and z minus beta whole square. Now we have to find the residues. Residues for the interior pole. Which is the interior pole? I by 3 is the interior pole. So as you know that beta is equal to, so what is our beta value? This is I by 3, which is interior to mod z is equal to 1. So this is mod z. So this value is beta and here it is alpha. Beta is the interior pole, and now for I by 3 is a pole of order. It is a pole of order 2. So here this is pole of order 2, and therefore the formula here is residue of f of z for z is equal to z naught is nothing but 1 by m minus 1 factorial into limit z tends to z naught. This is d by dz power, this is m minus 1 into this value is z minus z naught power m into f of z. So this is the actual formula, and in this what we have to keep, so m is the order value, so m we have to keep 2 here, and z naught is the pole value, we have to keep I by 3 or beta, or this value is beta. Beta value we have to keep. We have to keep the beta value. So beta is the interior pole. And now for finding the residue at the interior pole, f of z at z is equal to beta is equal to 1 by 2 minus 1 factorial into limit z tends to beta. This is d by dz power, this is 2 minus 1 into z minus beta par square into f of z, into the f of z value, which is equal to 2 minus 1 factorial is again 1. So therefore limit z tends to beta, that is d by dz into this is z minus beta whole square into f of z. So what is our f of z value? F of z value is this one, that is 4iz by 9 times of this is z minus alpha whole square into z minus beta whole square. Clear? And after cancelling this z minus beta whole square, and we have to make a derivative. So here 4I by 9 is a constant thing, so I am bringing it outside. This is limit z tends to beta. I have to make a derivative for one time. This is z by this value is z minus alpha whole square. For making derivative, what is the formula here? The formula here is u by v. So this is u by v. So this will be v square v u dash minus u v dash, u v dash. So in this formula, if I keep the derivative value will be, so this will be 4I by 9. This value is limit z tends to beta. So this is nothing but z minus alpha par 4. So this is again z minus alpha whole square. For z this is 1 and z you have to leave 2 times of z minus alpha. 2 times of z minus alpha. So this value is 4I by 9. This is limit z tends to beta. This is z minus alpha. If I take common, so this will be z minus alpha minus 2z by this is z minus alpha par 4. So if I cancel this for one time, so this will be 3. So this is 4I by 9 limit z tends to beta. So this value is minus alpha minus z by this is z minus alpha whole cube. So in place of z, I have to keep beta here. So this value is 2I by 9 into minus alpha. In place of z, I am keeping beta. That is beta minus alpha whole cube. Clear? So this will be 4I by 9 minus, if I take common, this will be alpha plus beta. And again, this is beta minus alpha whole cube. Whole cube. And what is our alpha and what is our beta here? So what is our alpha value? So alpha value is equal to 3I and the pole value beta value is equal to I by 3. So if I substitute alpha plus beta here, so what is our alpha plus beta? So alpha plus beta value is equal to 3I plus I by 3. Alpha plus beta value, if I take 3 common, this will be 9I plus I. So alpha plus beta value is equal to 10I by 3. And clear? And this is beta minus alpha. So what is beta here? I by 3 minus 3I. So if I take 3 common, this will be I minus 9I. So beta minus alpha is equal to minus 8I by 3. So alpha plus beta is equal to 10I and beta minus alpha is equal to minus 8I. See here, this is minus 8I. Alpha plus beta value is equal to, this value is 10I by 3 and beta minus alpha value is equal to minus 8I by 3. So if I substitute here, then this will become then the residue of f of z. So this is residue of f of z at beta z is equal to beta value is equal to this is 4I by 9 times of minus of what is alpha plus beta. This value is 10I by 3. This value is 10I by 3 by beta minus alpha. Beta minus alpha whole cube value is minus 8I by 3 whole cube. So this can be written as this is 4I by 9 into this is minus 10I by 3 and this value is 8 times here. So 8. So if I reciprocal it, this will be 3 cube, that is 3 into 3 into 3 by this is minus 8I into this is minus 8I into this value is minus 8I. Clear? Now 9 3s are 27 and this is also 27. See here, in 4 it goes in 2 times. So again this goes in 5 times. Here minus into minus into minus and here also minus. So here if you see, this will be I square minus 1. So this is minus 1 plus this value remains as 5 by, this is 8 8s are 64, and this is minus into minus plus, and this is again minus, and I square value is minus 1, and this value is I here. Clear? So these are the values remain for residue of f of z at z is equal to beta. Now we are going to apply which one we are going to apply residue theorem. So according to our residue theorem, so integral f of z dz is nothing but this is 2 pi I into sum of the residues. Sum of the residues. So this is sum of the residues at the interior poles. Sum of the residues at interior poles. So here the interior pole is beta, and therefore our residue value, that is integral. The question here is integral 0 to 2 pi. This is d theta by 5 minus this value is 3 sine theta whole square is equal to this value is 2 pi I times of 5 by 64 into I. So if I cancel in 2 times, so this will be 32, and I got cancelled, and therefore what remained here, integral 0 to 2 pi d theta by 5 minus 3 sine theta whole square value is equal to, this is 5 pi by 32. So this is the final value, and this is how we have to solve. Don't think that this video is lengthy, because I have explained each and every step very vividly, clearly, and nothing is skipped here, and therefore it is very lengthy. Please, you can try this. Definitely you can solve. See, first let me explain you once again. See, here is the question. We have to evaluate integral 0 to 2 pi d theta by 5 minus sine theta whole square using residue theorem. First of all, we have to take z is equal to e power I theta, and mod z is equal to 1 is the region. So it is a circle with center 0 and radius 1. So this is the region, and z is equal to e power I theta. So I made the value of d theta as dz by zi, and sine theta value is also very clear as z square minus 1 by 2 zi. Each and every step I have explained, that's why it's very lengthy. So these are all the values, and this is the integral. We have to substitute d theta as dz by zi, and sine theta value is this one, and after solving, taking LCM, so we got f of z value as this one. So after getting f of z, what we have to do? So we have to equate the denominator to 0. So after equating the denominator to 0, so we got the pole values as beta is equal to 3i, and alpha is equal to 3i, and beta is equal to I by 3. As it's very clear that 3 is more than 1. So this value is more than 1. Therefore, alpha value lies outside the circle and beta value lies inside the circle, as beta is less than 1 and alpha is greater than 1. So this is the interior pole, and this is outside the pole. So for interior pole, we have to find the residue. So in order to finding the residue, first of all, I have taken this f of z, and as beta value is I by 3 and the alpha value is 3i. So I have taken 3 common from this for my simplification, and see here. So in place of 10 by 3, I wrote 10i by 3, I wrote alpha plus beta. In place of minus 1, I wrote alpha beta, and clearly after um, solving, so I got the f of z value as this one. So after getting f of z value, so I have to calculate the residue value at the interior pole I by 3. So this is the formula. So it is a pole of order 2. Therefore m value is equal to 2 and z naught value is equal to beta. After substituting and cancelling and substituting the beta z value as beta, so this value I got, that is alpha plus beta by alpha beta minus alpha whole cube. So what is alpha plus beta and beta minus alpha? This is alpha plus beta, and this is beta minus alpha. After substituting here, clearly after substituting here and cancelling, I got, see here, this value is 10. This is 10 value. Cancelling, I got the residue value at the interior pole z is equal to beta is 5 by 64i. So I have to apply residue theorem. Residue theorem is 2 pi I into the sum of the interior poles residue value, that is 5 by 64i. If I cancel this one, 5 pi by 32 is the final answer. Thank you so much for watching this one. This is also very important. If you follow all these videos in the playlist, definitely this chapter will be very helpful for you. Each and every step I have given you a clarity. That's why it's very lengthy, and don't feel that the length of the video is very huge, large, and therefore you have to understand each and every step. While understanding, if it's easy, it will be very easy for solving the problem. Thank you so much. If you really like, what to do, please subscribe and pass it on to your friends. Thank you so much.